Global warming is a huge problem in today's society due to the increase in greenhouse gases present in the atmosphere. This is caused by factors such as the burning of fossil fuel in factories, the popularity of the private car, and the increase in the amount of livestock raised to feed the 7.5 billion people on Earth. Thus, our group decided to investigate the efficiency of Quicklime, sodium hydroxide solution, and lithium hydroxide solution at absorbing carbon dioxide from the atmosphere, thus providing a possible solution to reducing carbon dioxide emissions in the future.
For this experiment, we used bicarbonate indicator to determine the carbon dioxide concentration levels, 0.4 molar lithium hydroxide solution, 0.4 molar sodium hydroxide solution, quicklime, cling wrap, and beakers. Lots of them.
Oh, also, don't forget your safety equipment!
Firstly, put 10 milliliters of bicarbonate indicator into each of the 350 ml beakers. We have already completed this for 2 of the beakers. Next, place 10 ml of sodium hydroxide solution into the 500
Don't pour it in!
As I was saying, place 10 ml of sodium hydroxide solution into the 500 ml beaker. Do the same for the lithium hydroxide solution and the quicklime, but with different beakers. Place one small beaker containing bicarbonate indicator into each of the beakers containing the independent variables. Then, seal the opening of the beaker using cling wrap. Make sure the cling wrap is tight. So, how does our experiment work? Bicarbonate indicator is actually a pH indicator that is sensitive enough to detect the change in pH due to the change in the concentration of dissolved carbon dioxide in the solution. As the concentration of carbon dioxide increases, and thus the acidity of the solution, bicarbonate indicator turns from a reddish-brown color to orange, then yellow. In contrast, as the concentration of carbon dioxide decreases, its color turns to magenta, then violet or purple. Quicklime reacts with carbon dioxide to form calcium carbonate. Lithium hydroxide solution reacts with carbon dioxide to form lithium hydrogen carbonate. Sodium hydroxide solution reacts with carbon dioxide to form sodium hydrogen carbonate. After 1 day, we checked on the beakers. The bicarbonate indicator placed into the beaker containing sodium hydroxide and calcium oxide turned purple or violet, while slightly closer to magenta for lithium hydroxide. This shows that lithium hydroxide lowered the concentration of carbon dioxide by a small amount compared to the other two chemicals. This is surprising, as our research shows that lithium hydroxide is not only significantly more costly than both sodium hydroxide and quicklime, but it is also presently commonly used for carbon dioxide absorption. This may be caused by errors such as the contamination of equipment during the execution of our experiment. In conclusion, we have found out that lithium hydroxide is not as efficient as absorbing carbon dioxide compared to what we found during our research, though that may be caused by errors, and have shown that sodium hydroxide solution and quicklime are also viable and economic options to absorbing carbon dioxide, and thus reducing carbon dioxide emissions in the future.